In this video, we're going to start looking at the complex zeros of polynomial functions. So in the past, we've always just said that you cannot take the square root of a negative number. And this is true if you're only working with the real number system. But today we're going to start talking about the imaginary number system in which we're allowed to discuss the square root of a negative number. So to start with, we're going to define the imaginary unit I as being the square root of a negative 1. Okay, so I is equal to the square root of negative 1, which in turn would mean that I squared is equal to negative 1. Okay, so what we're going to call the complex number system is anything that's written in this form, a plus bi. So a is going to be the real component of the number, and b is the imaginary component of the number. So to start with, I want to just take a look at some simple examples of simplifying imaginary numbers to kind of show you how these work a little bit. So let's say we want to take a look at the square root of negative 9, okay, and I want to simplify this number. So when we think about something like this, we can start by just sort of breaking it up. So I'm going to separate out the square root of 9 from the negative part of it, okay? So square root of 9, that's easy. That's just equal to 3. And then based on the definition that I just gave you up here, the square root of negative 1 is defined as I. So when you're taking the square root of a negative number and you want to simplify it, take the square root of the number like normal, but the negative part of it just means that you tack an I onto the end of your answer. So similarly then, if we want to take the square root of a negative 36, well, square root of 36 is 6. Since it's a negative, it becomes a 6i. All right, now if you're looking at something like the square root of an 8, which isn't a perfect square, we can break it down like you normally would. So I'm going to separate this as the square root of 8 times the square root of negative 1. But then that 8 we can keep breaking down as the square root of 4 times the square root of 2. So the square root of 4 becomes 2. The square root of the negative 1 is an I, and then we still are just left with a square root of 2. And similarly, with the square root of a negative 27, again, split it up as the square root of 27 and the square root of negative 1. The 27 we can break down as a 9 and a 3. So then square root of 9 is 3. Square root of negative 1 is I. And then we're still left with the square root of 3. All right, so this is the basic idea with these complex numbers. When you have a negative under a square root, that's your imaginary unit I. So just take the square root like normal, add an I onto it when there's a negative, okay? All right, so then along with this comes this idea of a complex conjugate. So if our complex numbers are in this form a plus bi, when we change the sign in front of the imaginary term, this is what we call a complex conjugate. So the conjugate just changes the sign in front of the imaginary term. So again, a couple quick examples here. So if we have 2 plus 3i, the complex conjugate would simply be 2 minus 3i, just changing that sign. For minus 6i, the conjugate of that would be 4 plus 6i. Now be careful with this next one. We have a 7i plus 2. So the complex conjugate changes the sign in front of the imaginary term. So our complex conjugate would be negative 7i plus 2. And then similarly with this last one, negative 3i plus 5, our complex conjugate would be a positive 3i plus 5. All right, so that's basically all you guys need to know about imaginary numbers and complex numbers. So the reason we're going to be looking at these is because we're going to start trying to find the complex zeros of polynomial functions. So think about any time you're trying to take the square root of a negative number. In the past, we would have just said no real answer, but now we're going to start finding our imaginary answers that come along with these square roots of negative numbers. So in the next video, we're going to start looking at finding zeros of polynomials.